Hello everyone. As you know, our next topic is the remainder theorem. We have completed the factorization. Now we'll come to a remainder theorem. Here we'll have to find the remainder by using remainder theorem. You know what is the remainder? We use division and whatever left at the end after subtracting the different term. That is called the remainder. Here again we will find the remainder, but the method that we will use over here, that is the remainder theorem. So how we are going to use the remainder theorem? This polynomial is divided by x minus 2. Means we will divide this by x minus 2, but not using the traditional method of the division. We will divide this by using remainder theorem. So how are we going to use the remainder theorem? First we will take this divisor, that is x minus 2, and x minus 2 we will take the value of x from here, put equals to 0, minus 2 on the other side is plus 2. So the value of x is here 2. That value of x we will put here in the given polynomial. So the polynomial name is p of x because it involves with the variable x. Equals to 3. In place of x I will write 2. It has a cube. Minus 10. In place of x I will write 2. It has a square. Plus 13. In place of x I will write 2 and this minus 6. Now you can see from here p of x mean x, in place of x we have put here 2. 3. First we'll eliminate this power. Most of the students do that. First they multiply 3 by 2. No, that's wrong. First we will remove this power by taking the cube of 2, that is 8, minus 10, 2 times 4, 13 2 times 26, minus 6. So p of 2 means that in place of the x we have put here 2. 3 8 times 24, 10 4 times 40, plus 26, minus 6. Now we are going to solve this. We will simplify here 24 minus 40 plus 26 minus 6. That is equals to here 4. So by dividing the polynomial, this polynomial by x minus 2, we got here 4. The 4 is the remainder of this polynomial. So in such a way we can find the remainder if a linear divisor, x minus 2 type divisor, linear mean in which the power of the variable is 1, that is not higher than 1. So we can find the remainder in such a way. Yes guys, here you can see the part 2. Again the polynomial involves here x and this is divided by 2x minus 1. In the same way, first we will find the value of x from here. 2x minus 1 on the other side is plus 1. X is here 1 and 2 is multiplied here on the other side. This will be divided. So the value of x is here 1 by 2. So what we are going to do, first we write this as a polynomial p of x. 4. In place of x I will put the value 1 by 2. It has a cube. Minus 4. In place of x I can write 1 by 2 plus 3. P of x means we will put here the value 1 by 2. 4. First we will open this cube. 1 over 2 multiplied 3 times. 1 time 1, 1 time 1. 2 cube equals to 8 minus. This can be cancelled, but in the next step we will do it. Here you can see 4 1 times 4, 4 2 times 8, 2 1 times 2, 2 2 times 4. This is now 1 by 2 minus 2 1 times 2 plus 3. Okay, now what we'll do over here? Because here is the fraction, so we we are going to take the LCM over here. The LCM of all these, here it will be 1. The denominator is 1, that is 2. 2 divided by 2, that is 1. 1 multiplied by numerator 1, that is equals to 1. 2 divided by 1, 1 2 times 2, that 2 multiplied by the numerator 2 times 4. Again 1, this 2 divided by 1, 1 2 times 2, 2 multiplied by 3 is 6. Okay, 6 plus 1, 7, 7 minus 4 is 3 by 2. So here, the remainder of this polynomial is 3 by 2. Okay, well students, here you can see the part 4. Part 3 will try to do yourself. All parts are of the same type. So part 4 is given over here, and this is divided by 2x plus 1. So in the same way, use the remainder theorem. The value of x plus 1 on the other side minus 1, x equals to minus 1 over 2 on the other side is divided minus 1 by 2. So here in place of x, what we are going to put minus 1 by 2. So polynomial p of x equals to 2 minus 1 by 2, then minus 1, and it has a cube over it, plus 6, then 3 plus 4. In place of x, I will put minus 1 by 2. It has a square, and minus 10. Okay, now how I'll simplify this p of minus 1 by 2? Simply, it has no power, so 2 will be cancelled by 2. This is minus 1 minus 1. Minus minus plus. Sign will be of minus 2 cube plus 6, 3 plus minus minus. This will be cancelled. 2 times 4. This 2 1 times 2. It has a square over it, and minus 10. So p of minus 1 by 2 here. The cube of minus 2 is minus 8 plus 6. 3 minus 2 is 1. It has a square over it, minus 10. Now you can see from here minus 8 plus 6. The square of 1. 1 times 1 minus 10. Minus 8 plus 6. 1 times 6 minus 10. Okay, here you can see minus 8 minus 10 minus 18 plus 6, that is equals to minus 12. So here you can see the remainder is minus 12. After this we are going to solve its part 2. So part 2 is also we can solve with this by using the same remainder theorem. Question 2 part 1, that is if x plus 2 is a factor of this given polynomial, then find k. We will solve, so we will have to find here the value of k, and we will use here the remainder theorem. You can see here this is the linear divisor x plus 2, and again in the same way we will find here the value of x that we will put in this polynomial. So this side I can do x plus 2 equals to 0, x equals to minus 2. So that I will put over here. P of x equals to 3. In place of x I am going to put minus 2 square minus 4k. In place of x I will put minus 2 and then minus 4k squares. You can see I have put here the value minus 2 equals to 3 minus 2 square, that is minus minus plus 2 times 4 minus minus plus 4 times 8k and minus 4k square. Okay, from here 3 4 times 12 plus 8k minus 4k squares. You can see from here that this is now the quadratic equation. Quadratic equation in which the variable k is involved. This is k square, this is k, and this is the constant term. So with the variable k, now this is the quadratic equation. So we are going to solve this with the midterm break method. We can use the first I will arrange and take the common from here. The common here is 4 because 4 is divisible, that is 8, 12 and 4. They are divisible by 4. So 4 will be common. First I will arrange, I will write this. I can take here the common minus 4, that is k squared. Minus I have taken the common, both the signs will be changed. This is minus 4 2 times 8k, and here plus will be minus 4 how many times 12? 4 3 times 12. Okay, you can see that here is this is the equation now, because we can say that here in the question it is given that x plus 2 is the factor of polynomial, as x plus 2 is factor of polynomial. So when any divisor is the factor of polynomial, then remainder is equals to 0. Its remainder is equals to 0. So this is the remainder now that we will put equal to 0. Why we put this equal to 0? Because x plus 2 is the factor of polynomial. We have to write this reason over here. So minus 2, minus 4, and this. Minus 4, you can say this is not equal to 0. This is minus 4, this is less than 0. But here it involves a variable. So we don't know this is equal to 0 or not. So we'll put this equals to 0. K squared minus 2k minus 3. Okay, now we are going to do here the midterm break. 3, the factors of 3 will be k squared minus 3, I will write as it is. The factors of 3 will be minus 3k plus 1k. Because minus 3 plus 1 we will get minus 2, and after multiplying these two we can get minus 3. So I will make the pairs over here. Here common is k. So k minus 3 is left. Here nothing is common, the 1, k minus 3. Here you can see that both k minus 3 are the same factors. It will be common. And what is left? K plus 1. And I have put this equal to 0. Because both we have remainder is equals to 0. So we put this equals to 0. Okay. Now the both factors I will put equal to 0. That is k minus 3 equals to 0. And the second is k plus 1 equals to 0. So k is equals to minus 3 on the other side is plus 3. This is the first value of k. And k equals to plus 1 on the other side is minus 1. This is the second value of k. Part 2 of question number 2. In the same way, x minus 1 is the factor of this given polynomial. So we'll find here the value of k. We will use again here the remainder theorem. First we write the polynomial, that is x cube minus kx squared plus 11x minus 6. So it is x minus 1 equals to 0 equals to minus 1 equals to plus 1. So we are going to put here the plus 1 cube minus k into 1 squared plus 11. In place of x I will write 1 minus 6. The cube of 1 equals to 1 minus the cube square of 1 is 1. 1 multiplied by k is k. 11 1 times 11 minus 6. Only minus k is here. Rest of all the constant values 11 plus 1, that is 12. 12 minus 6 is 6. So this will be minus k plus 6. Once again I will have to check for any correction. I have written the polynomial x cube minus kx squared plus 11x minus 6. Okay, that is okay. 1 I have put here minus k 1 square plus 11 into 1 minus 6. Okay guys, this is correct. Okay, further we are going to solve this as x minus 1 is factor of polynomial. They said in the question that x minus 1 is factor of polynomial. So when divisor is the factor of polynomial, and that is the exactly divisible by polynomials, we can say that remainder is equals to 0. So this remainder will be put equals to 0. Minus k plus 6 equals to 0. We have to find here the value of k. Minus k on this side plus 6 on the other side is minus 6. Both minus are cancelled. So k will be equals to 6. So this is the the value of k over here.